Good morning, all of you. Are you able to hear me?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, aromatic hydrocarbons, have I started with you?
No.
Okay, I haven't started. And hydrocarbons was completed, no? Till alkynes.
Yes, ma'am.
Okay. How was your TWT?
Was good.
Yeah, she was good.
Chemistry was good. You were able to
Yes.
attend all questions?
Yes, ma'am.
Yes, ma'am.
Okay, that's good. That's nice. Okay. So let us start with aromatic hydrocarbons. I thought I have already taken one.
You are teaching hydrocarbon.
Sorry?
You are teaching aromatic hydrocarbons right now. You are solving the booklet.
Booklet, how much I have done, like?
The others are discussed till exercise 3 of hydrocarbons.
Exercise 3 tak ho gaya hai na? Did you all solve the entire thing, right?
Yes.
Okay. So what I'll do is next week we'll arrange a doubt class. Us doubt class mein I'll take booklet discussion.
Ma'am, tomorrow you have a doubt class 5 to 7.
So then that I can take booklet discussion. Fine. So let us start with aromatic hydrocarbons. Now under this, the first thing which you are supposed to know is aromaticity. I have already done aromaticity. Aromaticity is classifying the molecules into either aromatic, non-aromatic or anti-aromatic compounds. I have done this in GOC. Yes?
Yes, ma'am.
I'm not going to repeat this part. This is aromaticity is basically classifying a molecule into aromatic, non-aromatic and anti-aromatic systems. So now let us start directly with preparation of benzene. First method is this is the industrial method by fractional distillation of petroleum. What's petroleum?
Isooctane.
That is petrol. Petroleum is a mixture of all hydrocarbons basically. So petroleum is a mixture of alkanes, alkenes, alkynes, and aromatic hydrocarbons. So from crude petroleum, you need to separate out benzene. Now these petroleum, as I said, is made up of alkanes, alkenes, alkynes, and aromatic hydrocarbons. They'll have difference in their boiling points. So what is done is fractional distillation is carried out. Do you know what is fractional distillation? Have you heard about fractional distillation?
One little.
Okay, it's a method of separation of a mixture, into its components based on the principle of difference in boiling points. Okay, so if there's a difference in boiling point, you can go for this method. School में नहीं किया है क्या distillation वगैरह?
Yeah.
Yes, we did.
हाँ. So here fractional distillation is carried out to separate all the components of crude petroleum, in which one of the component would be benzene. Okay. So this is of course an industrial method. The other methods which I'm going to do are chemical methods. Next is from acetylene. What's acetylene?
Ethyl.
Yes, acetylene is ethyl. Now ethyl when passed through a iron or copper tube, which is heated to red hot. Okay, so ethyne or acetylene when passed through an iron or copper tube, which is heated to red hot. It undergoes cyclic trimerization. Do you know what is trimerization? Polymerization क्या होता है?
Formation of
See, polymerization is formation of a polymer
Polymer, yes, ma'am.
where large number of molecules combine to form a single molecule. So trimerization will be
Must
what?
3 molecules combined to form a big
Yes.
molecule.
combined to
Three
form one.
molecules here will combine to form a single molecule. So in the presence of this iron or copper tube, this pi bond will be shifting here to form a sigma bond between carbon and carbon, simultaneously causing this pi bond to shift, which again simultaneously will cause this pi bond to shift here. In other words, I'm going to get this. What's this?
Benzene.
Benzene. Okay. So acetylene undergoes cyclic trimerization. Then you pass it through copper or iron. Did you finish writing this? Okay, so I'm proceeding ahead. Smith, I said that acetylene undergoes cyclic trimerization in presence of iron or copper tube to give you the formation of benzene. Okay, what if I take instead of ethyne, if I take propine, then what would I get?
Toluene.
We'll get toluene.
Time.
Ma'am, acetylene.
Yes. Okay, you'll get mesitylene. So you'll get symmetrical trimethyl benzene. Symmetrical trimethyl benzene or 1,3,5 trimethyl benzene is known as mesitylene. So this was the first method of preparation. Second method is using
Acetylene name, no?
sorry,
Common-
no, your voice is not, I'm not able to hear you.
Ma'am, mesitylene is the common name.
Yeah, mesitylene is the common name. Next is using Grignard reagent. Yes, it is a third method, sorry. because first was that petroleum distillation. Grignard reagent, you'll be using phenyl magnesium bromide or phenyl magnesium halide. Any halide you can take here. What would I need to convert it into benzene? Look at the reactant and look at the product. What I need to do here?
Alcohol.
Yes, you can add water or alcohol. Any protic compound. What will the protic compound do?
Remove the BR.
It will remove the
Protic compound means what?
it can form an H1.
Form hydrogen bond.
Can I say yes? It can also give H plus ions.
Yes.
Yes, ma'am.
So it will give H plus where?
Br.
Which is more reactive? Carbon with negative?
No,
or-
no, it's carbon with negative. Sorry.
So H plus will go to here, this carbon. So I'll get benzene along with Mg, Br, OH or Mg, Br, OR, depending on whether you've taken water or alcohol.
Yes, mass.
This method I've already done na, in the preparation of alkanes. Grignard will react with any protic compound to give H plus ions to give you the corresponding alkane. Here you can use it to prepare benzene. Did you all understand this method?
Yes,
Yes,
mass.
ma'am.
Did you all finish writing this?
Done.
Grignard वाला I said that Grignard पे negative charge होता है ना carbon पे. So any protic compound, protic means H plus will be given by these compounds. That H plus will go to carbon and you will get the negatively charged carbon will accept the H plus to give you the corresponding hydrocarbon. Fine, Sai, you understood? Okay, let's proceed ahead. What if I want toluene? How many different Grignard reagents would give me toluene? Come on, tell me.
Plus 2.
No,
3,
no.
no, 5,
5, no, my dear, 4. How 4?
para, meta,
Yes.
also.
Okay. Yes. So if I treat this with water or alcohol, I could also go for this.
Aprotic.
नहीं, aprotic तो नहीं use कर सकता. I can use Grignard here. Correct?
Yes, sir.
इसके तीनों हो सकते हैं. कौन से? Ortho, meta, para.
Also meta.
So total, how many Grignard reagents would give you toluene?
4.
Yes.
4.
Did you all finish writing this?
And they can't be on the same carbon, MgBr and the methyl group.
Same carbon nahi, because there is no carbon cannot form 5 bonds. Because this
Yes.
carbon has already formed 4 bonds. देखो,
Okay, ma'am.
this carbon has bonded. It has double bond this side, single bond here and this. So 4 bonds are already there.
Yes, ma'am.
You cannot have a magnesium bond. Yes, Dave, this is the first lecture of aromatic hydrocarbons. Not hydrocarbons, it is aromatic hydrocarbons.
Must here also any protic solvent is fine, right?
Yeah. You can also use acid. कोई भी acid भी use कर सकते हो.
Okay, must.
Ma'am, what have you written the OMP?
Ortho meta para. Benzene sulfonic acid. Benzene sulfonic acid is benzene with a SO3H group. I have done this reaction earlier, if you remember. Where have I done this?
Hydrocarbons में नहीं.
Hydrocarbons में नहीं किया है.
GSC.
I have done this under reaction mechanism, under sulfonation of benzene, if you remember. इसका reverse reaction किया था.
Yes, ma'am.
Sulfonation of benzene means benzene, when treated with sulfuric acid, gives you benzene, sulfonic acid, and water. And I had told you that the reaction is reversible. Do you remember?
Yes, ma'am.
Yes,
Yes,
ma'am.
must.
So you can reverse this reaction by taking the benzene, sulfonic acid, and water and boiling it. So you'll get benzene.
Just the cardless. Just the cardless.
Have you finished writing this?
Done, ma'am.
Okay. Next is from phenol. Phenol to benzene. Basically, what we are supposed to do here?
Remove the
Yeah.
OH.
Can I say remove oxygen? I have to just remove the oxygen, correct?
Yes, must.
Yes.
So for removing an electronegative atom, you require a metal. The metal used here is zinc. Zinc will remove the oxygen. You know, zinc is also used for dehalogenation,
Yes, ma'am.
for removing halogens. So for removing any electronegative atom from a molecule, you have to add a metal, and the metal to be used here is zinc.
Can you repeat again what you just said?
I said to remove any electronegative atom from a molecule, you need to use a metal.
And zinc is preferred here.
Yes, and the metal which we use here is zinc. You know what will zinc do? Zinc has to do what?
Give electron.
Yes. How many electrons can zinc give?
2.
Can I say it is very difficult to break the oxygen carbon bond here because of
Yes,
double?
must.
There's a partial double bond character. So first thing what will happen is zinc will come and donate 2 electrons here. So as zinc donates 2 electrons, what will happen? This bond will break. because now the carbon will not accept electrons from oxygen by resonance. So जैसे ही वो bond break होगा, these are the two electrons provided by zinc. What formal charge will the carbon get?
Negative.
Yes.
-2.
It's 2 negative.
No, only minus. Get a negative charge. So this H plus will come out. H plus will go with that carbon, giving you what? Benzene. And the oxygen here will be taken away by zinc, forming zinc oxide. Next method is from benzene diazonium salt. Do you know what is diazonium salt?
Nitrogen.
I'll just write it. This is benzene diazonium chloride. See, it has a benzene ring, and how many nitrogen in the molecule?
2.
So diaza, am I right? So diazonium, because it is positively charged, nitrogen, its name will end in em. Diazonium. Salt hai kyunki you have positive and negative ions in this. Now, how is benzene diazonium salt prepared? Benzene diazonium salt is prepared from aniline. Aniline, when treated with NaNO2, that is sodium nitrite, in presence of HCl, at a temperature of 0 to 5 degrees Celsius, you get the formation of benzene diazonium salt. Sorry.
And do we have to write this?
Yeah, just write down the preparation also. इसका preparation का जो mechanism है, I'll be taking under. ये preparation का mechanism I'll be taking under amines. इसका पूरा mechanism I'll be taking under amines. Benzene diazonium chloride when treated with H3PO2. H3PO2 is called as hypophosphorus acid. Hypophosphorus acid. You get the formation of benzene along with the liberation of nitrogen. You get H3PO3 and HCl. H3PO3 is orthophosphorus acid. It's a redox reaction. Could you identify the element undergoing oxidation?
N2.
Okay.
Acid.
Which
The
acid?
N2 is going redox.
Hypophosphorus acid.
Going from what state to what state? Basically, phosphorus
Plus
is getting
1, 2, plus 3.
plus 1, 2, plus 3. Very good. And you had said nitrogen. Could you give me the?
It's going under reduction.
It's undergoing
Gain of
reduction.
electrons.
No. What is oxidation number of nitrogen in this diazonium salt? This is not its oxidation number. This is the formal charge.
-1.
Yeah, oxidation number is -1. Changing into what?
0.
0.
So nitrogen is undergoing what?
Oxidation.
Yes, oxidation. So both nitrogen and phosphorus are getting oxidized. I want you to identify the element undergoing reduction now.
benzene,
क्लोरीन
नहीं, क्लोरीन तो वहां पर भी -1 है, यहाँ पर भी -1।
Phosphorus.
हाइड्रोजन
मैम बेंजीन का रिंग, the
हाँ,
benzene
बेंजीन का
carbon
ये कार्बन
plus
Give me
1 to
the-
0.
+1 to -1, not 0. Why -1? Because now it's bonded to hydrogen.
Yes, ma'am.
So with hydrogen, which is more electronegative, carbon or
Carbon.
हाँ.
कार्बन
So carbon will acquire a oxidation number of -1. So carbon undergoes reduction.
Ma'am, what mechanism did you say you will do in amines chapter?
This part.
Okay, ma'am.
Preparation of diazonium salt. You have finished writing?
Mas.
हाँ, बोलो.
Mas, could you show the previous page for a second?
Yeah.
Done, Mas. Thank you.
This is done. I'm proceeding ahead. So now methods of preparation are done. Now I'm proceeding to the reactions of benzene.
we are done with preparations.
Yeah, preparations are done. Okay, which class of reactions would benzene prefer undergoing?
Addition.
substitution
Substitution.
Which type of substitution?
electrophilic
Electrophilic.
Electrophilic.
So benzene readily undergoes electrophilic substitution reactions. Yes. Okay. Under this, I have done nitration of benzene. I have covered sulfonation of benzene. Halogenation of benzene is done. I have done Friedel-Crafts alkylation. I have also done Friedel-Crafts acylation. So these electrophilic substitution reactions have been already covered. Am I right?
yes ma'am.
So I won't be doing these again. I'll proceed to the next one. Just write down these and just write it down that you have done it under reaction mechanism.
चार पांच मिनट होते थे
Did you all finish?
Done.
Okay. Now I'll take the next one, that is Gatterman-Koch. Gatterman-Koch reaction. In this, you take benzene with carbon monoxide and HCl. You have to use a Lewis acid here, that is anhydrous aluminum chloride. You get the formation of benzaldehyde. In fact, HCl is the product also.
Ma'am,
No.
what's the spelling for Gatterman you have written?
Fine.
Yes, ma'am. Thank you, ma'am.
Oh. What will AlCl3 do? Come on, tell me.
Take the
Lewis acid.
HCl minus.
Yes, it will take away the Cl. First step, all of you have understood?
आणि रायन टेंडोस्टेट खबर है पहला वाले टैलेंट में वो वर्ल्ड कप में 41 इयर्स एवर वर्ल्ड कप
Rahil, I think some sound is coming from your place. Okay. First step, all of you have understood?
Yes.
Give me the formal charges here. Carbon monoxide.
Carbon minus.
Minus plus
And what is the oxidation number of carbon here?
-3.
Oxidation number of carbon. You have done redox?
Yes.
You all know to how assign na? Oxidation numbers.
चल रहा है मैम.
Oxidation number तो assign करने आ गया होगा अभी तक.
Yes, ma'am.
अभी वॉल्यूमेट्रिक कर रहे होगे ना टाइट्रेशन.
No,
मैम
ma'am.
इलेक्ट्रोकेमिस्ट्री चालू हो गया.
हाँ तो वॉल्यूमेट्रिक खत्म हुआ मतलब करेक्ट.
यस मैम.
ऑक्सीडेशन नंबर बताओ कार्बन का.
+1. Sorry, -1.
मैम -2.
+2.
या ऑक्सीडेशन नंबर इज +2 ऑन कार्बन. एंड ऑक्सीजन का क्या होगा?
-2.
-2.
दिस इज अ कोऑर्डिनेट बॉन्ड. एक बॉन्ड कोऑर्डिनेट है एंड इट्स फ्रॉम अ मोर इलेक्ट्रोनेगेटिव टू
हाँ
लेस.
समझ उसका नहीं काउंट करने का ना.
हाँ इसका काउंट नहीं करना है. और बाकी के दो बॉन्ड्स हैं तो दो बॉन्ड्स के लिए कार्बन पे +2 आएगा और ऑक्सीजन पे
ऑक्सीजन का -2. यस मस.
ओके. अब H प्लस कहाँ पर अटैक करेगा पहले वो बताओ।
C minus.
Carbon.
हाँ, कार्बन अपना लोन पेयर शेयर करेगा उसके साथ। इसका रेजोनेटिंग फॉर्म
नहीं होगा ना। हाँ होगा।
now tell me where is the formal charge?
ऑक्सीजन
It's on
नहीं,
carbon.
कार्बन
Positive.
कार्बन
Carbon
पॉजिटिव।
will have a positive.
इन दोनों में से स्टेबल कौन सा है रेजोनेटिंग फॉर्म?
कार्बन
The
वाला।
right one.
Right one, ma'am.
थर्ड वन, राइट वन।
रीजन?
Positive on
Positive
carbon.
on
Charge on
most
carbon.
electropositive.
What is the first thing you'll check for stability?
Complete.
Octet rule.
Did you check that?
No ma'am.
So give me the answer.
Left one is more stable.
So can I say this is reactive?
Yes, ma'am.
Yes ma'am.
So this will react. इसमें किसी को भी इलेक्ट्रॉन नहीं चाहिए सर, सबके ऑक्टेट और ड्यूप्लेट कंप्लीट है, am I right?
Yes, ma'am.
इसमें कार्बन को इलेक्ट्रॉन्स चाहिए because उसका ऑक्टेट इनकम्प्लीट है. So that carbon will approach the benzene and it will replace the or displace the hydrogen, giving you benzaldehyde. H plus जो बाहर आया है, that H plus will go back to AlCl4 minus. Take the Cl back and you'll get the catalyst regenerated, that is aluminum chloride. Did you understand Gatterman gauge?
Yes, ma'am.
Mas, could you please explain the more stable and more reactive part?
The first one here is more stable because octet complete है ना सबका. Hydrogen
Yes,
का
Mas.
duplet complete है. Reactive तो वो दूसरा वाला है because carbon का octet incomplete है.
Okay, Mas, that's the only reason.
क्या है?
Okay, Mas, thank you.
Did you all finish writing?
Yes, ma'am. Minute, ma'am.
Okay. Aromatic hydrocarbons का booklet have you started doing?
Yes, ma'am.
एक एक्सरसाइज तो मैं
मैम एक एक से डिस्कस हो गया.
Complete कर लेना वो भी booklet. Okay? हो गया है मेरा पूरा.
Mas, पूरा?
Aromatic, हाँ, aromatic hydrocarbons today I'll complete.
Okay, Mas.
मैम नेक्स्ट क्लास से कौन सा चैप्टर है?
Next class है halogen derivatives, alkyl and aryl halides.
Mas, how big is that chapter?
No, that is also small. I think 2 or 3 lectures I'll complete.
Okay, Mas.
मैम आपने एसएससी टेक्स्ट बुक से कौन से चैप्टर्स करने को बोले थे?
HSC ना?
हाँ हाँ.
Alkyl and aryl halides. Alkyl and aryl halides.
ओके मैम.
Mas, could you please show page 5 for a second?
Yeah. This is 6, I think. Okay. No, that was 5 only.
Done, Mas. Thank you.
Okay, this is done.
Done.
Ma'am, and Gatterman rearrangement will take place.
नहीं, rearrangement नहीं हो सकता है यहाँ पर, क्योंकि can I say यहाँ पर जो कार्बन है जिसपे प्लस है, that is stabilized by back bonding.
Yes, ma'am.
हाँ, तो बैक बॉन्डिंग वाले कार्बोकैटायंस कभी भी रीअरेंज नहीं होते because these are the most stable कार्बोकैटायंस, correct?
Yes.
हाँ, so don't do rearrangements for these type of carbocations. Next is Gatterman aldehyde synthesis. Gatterman aldehyde synthesis. Now here benzene is treated with HCN. In presence of anhydrous AlCl3 to give you this compound. Okay, now what functional group is this? When you have a carbon with a single bond, carbon nitrogen single bond. So what functional group is this? It's an amine.
Amine.
When you have a double bond between carbon and nitrogen, it is called as an imine. And when you have a triple bond, it is called as a cyanide or nitride. So here we have a double bond. So it is going to be called as
Imine.
This is benzylamine. This on hydrolysis in acidic medium gives you benzaldehyde and ammonia. So let us see the mechanism. First step again will be the same. You'll get AlCl4 minus and H plus. Tell me where will H plus attack now? Where should H plus attack?
On the carbon.
Nitrogen पे lone pair है ना, delta minus भी है, so it will attack nitrogen. So nitrogen will share its lone pair with hydrogen. What formal charge on nitrogen?
Positive.
Positive.
इसका resonating form क्या होगा? Which is more stable form?
The left one.
Yes. Can I say this is more reactive?
Yes, ma'am.
Yes, ma'am.
So the reactive one will go to benzene and replace the acidic, replace the H plus. This H plus will again go back to AlCl4 minus, giving you HCl and AlCl. Formation of benzylamine, you all have understood?
Yes, ma'am.
Yes.
So now the hydrolysis of benzylamine, I'll take it on the next slide. Just copy this first. Did you all finish writing this?
No, ma'am. Wait.
हो गया?
Done, ma'am.
Okay. So now the hydrolysis of imine. Hydrolysis here is carried out in acidic medium. Where should H plus attack in the first step? Yes. So it will go and attack the lone pair. Nitrogen will share its lone pair. Give me the formal charge on nitrogen.
Plus.
Now because of this plus charge, the pi bond will shift the pi electrons to nitrogen. What charge would carbon get?
Positive.
Plus.
But then water acts as a nucleophile and it attacks carbon. So oxygen now will donate electrons to carbon. Give me the formal charge on oxygen.
Plus.
Plus.
Now there would be an IMP. What is IMP?
Molecular proton.
Yes, intramolecular proton exchange. So could you tell me what would happen here? Proton
H
exchange.
goes.
This H plus will come out from here. Electrons will be given back to oxygen. जैसे ही H plus बाहर आएगा, that H plus will attack where?
NH2.
Yes. So oxygen has got back the lone pair. And the H has migrated to nitrogen. What charge on nitrogen now?
Positive.
Plus.
Now this becomes a very good leaving group. This will leave out as well.
Ammonia.
And because of that, what charge should develop here? This takes the
Plus.
electron. So simultaneously what happens is this oxygen donates the lone pair. Now give me the charge on oxygen.
Plus.
Plus.
So now last step में ये H plus बाहर आ जाएगा और ऑक्सीजन को लोन पेयर मिल जाएगा, giving you benzaldehyde. The hydrolysis mechanism.
Ma'am, water attacks it from the opposite side as the NHH.
Yes, yes.
Okay. Ma'am.
Did you all finish?
Yes, ma'am. Done.
Okay. So all the electrophilic substitution reactions are done. Now I'll take up the addition reactions on benzene. Addition reactions are not very common on benzene. Why? What should be the reason?
It will become less stable.
Yes, because benzene is stable because of its presence of pi electrons, which are involved in resonance, correct?
Yes, ma'am.
If addition occurs, means it will be the pi bonds it will lose. All the pi bonds will become sigma bonds. Can I say aromaticity nikal jayega?
Yes,
Yes, ma'am.
And that is why addition reactions are very less common on benzene. So all the addition are carried out in drastic conditions. What do you mean by drastic conditions? High temperatures and high pressures. Okay. So first is addition of hydrogen. Okay. How many pi bonds in benzene?
3.
3.
So 3 moles of hydrogen will be added per mole of benzene. The catalyst to be used is nickel or platinum. Product form will be cyclohexane. Process is exothermic. The amount of heat evolved here will be called as heat of hydrogenation of benzene. Can I say cyclohexane is more stable than benzene?
No.
Process exothermic है ना?
Yes, ma'am.
Exothermic में कैसा होता है ग्राफ? ऐसा होता है ना? ये रिएक्टेंट है, ये प्रोडक्ट का एनर्जी जब लोअर होता है, can I say then the process is exothermic?
Yes.
So this tells you that since the process is exothermic, cyclohexane is more stable than benzene. It should be, na, because can I say all these pi bonds are becoming sigma bonds here?
Yes, ma'am.
So sigma bonds are definitely more stronger. So the energy which is going to be taken up by the molecule in order to break its pi bonds will be less than the energy which is going to be released when sigma bonds are formed here.
Ma'am, but it has lost its aromatic nature, no?
So because of that, the heat of hydrogenation is very less. Because of that, the heat of hydrogenation, which we calculate, according to that, it is very less. Rajdeep, IMPE was intramolecular proton exchange. Say, for example, per double bond, if the heat of hydrogenation I calculate is, say, 40 kilocalories per mole. How many pi bonds in benzene?
3.
So it should give out how many? It should
120.
120.
If 120 is calculated for 3 pi bonds, but it actually doesn't give out 120. Okay, it gives out 36 units less. 120 minus 36 kitna hoga?
88.
So if it is giving out 88 nahi.
MS 84. 36.
So if it gives out 84 kilocalories per mole, मिलना चाहिए था 120, मिल रहा है 84, तो बाकी का वो 36 कहाँ गया?
To break the aromaticity.
Yes. So can I say that is the resonance energy?
Yes.
Okay. You must have done questions on this in thermodynamics. How to calculate resonance energy. Okay. So this is the calculated heat of hydrogenation, but this is the observed. ये calculated है और ये observed heat of hydrogenation. So difference of 36 kilocalories per mole is there, and where is that difference going? That 36 kilocalories that is being used up to break the resonance in benzene, and that is why 36 kilocalorie per mole is nothing but the resonance energy of benzene. समझा कि नहीं?
Yes, sir.
So though we expected more, but we got very less heat, and that is because of the stability of benzene. Now partial reduction can also be carried out here. Complete reduction gives cyclohexane. Partial reduction of benzene can be carried out using Birch reduction. Birch reduction में क्या use करते हैं?
Lithium and liquid ammonia.
Lithium or sodium and liquid ammonia. You'll get the formation of this. I'll do the mechanism here. Just write down the reaction.
Mas partial reduction is under addition of H2 only.
Yes, yes.
Okay, mas.
Did you all finish?
Yes, mas.
Sai, you wanted the previous slide. This is the one. Okay. So now I'm doing the mechanism of Birch reduction here. Have you started writing the reactions in a tabular form?
Yes, ma'am.
Is it helping you?
Yes.
Yes, ma'am.
You can use lithium or sodium here. What does a metal do in a reaction?
Donate
Give electrons.
Lithium can donate how many?
one.
One.
Can I say it can give to any carbon because all are same here?
Yes, ma'am.
Yes, ma'am.
Supposing it gives electron to this carbon, it will cause the pi bond to shift to the other carbon. So this is the electron given by lithium. These are the pi electrons which have shifted here. Which carbon has a formal charge?
The one.
Right, positive, left, negative.
इस पे
One left,
positive,
one negative. Yes.
यहाँ पर H भी है, don't forget that. This is a free radical. This is not having any charge.
No charge.
क्योंकि कार्बन के कितने बॉन्ड्स हैं यहाँ पर?
4.
3 बॉन्ड्स हैं यहाँ पर, तो 3 इलेक्ट्रॉन कार्बन के यहाँ पर है और ये 4th इलेक्ट्रॉन. So will it have any charge?
No. No.
This is a radical anion. I have told you that in Birch reduction, the intermediate is always a radical anion. याद है मैंने किया है पहले Birch reduction.
Yes, ma'am.
अब इसमें resonance होगा. ये pi bond break होगा. This electron and this electron will pair up to form a double bond, and this electron will be transferred to this carbon. So this is the resonance of the free radical. समझा या नहीं समझा? H लिखने की जरूरत नहीं थी. Okay. Now, which of these two forms is more stable? ये रेजोनेंस में कौन सा ज्यादा स्टेबल होगा? ये फर्स्ट वाला या सेकंड वाला?
फर्स्ट वाला.
Second.
Second one.
Second one.
Reason you all are supposed to give.
First one is conjugated.
Conjugated.
Yes, first
First
one is
one.
conjugated, so more stable. Correct? So can I say this is
Yes.
more reactive?
Yes, ma'am.
So now ammonia is protic. Protic means what? It will give H plus. तो यहाँ पर
Yes.
H plus एक H already था, एक H और आ गया वहां पर. Can I say free radical is electron deficient?
Yes,
So
ma'am.
one more lithium will come and give an electron there. What formal charge on that carbon now?
Minus.
So ammonia आके H plus देगा वहां पर भी, and you get the reduced product. You'll finish the mechanism.
1 minute.
Ma'am, can you explain the second and third step?
First step समझा है ये?
Yes, ma'am.
ये resonating form समझ में आ गया?
Yes, ma'am. मैम उसमें वो बॉन्ड डिसोशिएट क्यों हो जाता है दो इलेक्ट्रॉन्स पे?
कौन सा?
रेडिकल अनायन में मैम.
कौन सा बॉन्ड ये बोल रहे हो?
Yes, ma'am.
ये रेजोनेंस है ना, ये इलेक्ट्रॉन और ये इलेक्ट्रॉन पेयर अप होके डबल बॉन्ड यहाँ हो जाता है.
Okay, ma'am.
और ये इलेक्ट्रॉन इस कार्बन पे आ जाता है.
Yes, ma'am.
हाँ, फिर अमोनिया प्रोटिक है. प्रोटिक मतलब H प्लस आके दे देगा इसको कार्बन आयन को, तो कार्बन आयन H प्लस ले लेगा एंड यू विल गेट दिस.
Yes, ma'am.
फिर जो फ्री रेडिकल है वो इलेक्ट्रॉन डेफिशिएंट है क्योंकि ऑक्टेट इनकम्प्लीट है. तो
Yes,
और
ma'am.
एक लिथियम आएगा और एक इलेक्ट्रॉन देगा. अगेन
Yes,
यू विल गेट अ कार्बन आयन जिसको अमोनिया के H प्लस दे देगा.
Yes, ma'am. मैम ये और कंटिन्यू होगा क्या?
नहीं, बस यहीं रुक जाएगा.
Okay, ma'am.
So mechanism, I think all of you have written.
Done, ma'am.
Okay.
Done.
So now, if you take something like this, what is the name of this compound? Toluene. Toluene, if you bring about Birch reduction. You get this. But if you take something like this compound, this is benzoic acid. With benzoic acid, you get this. Why is the difference in the position of the pi bond? Can I say this is an electron donating group?
Withdrawing and donating. Yes.
This is electron withdrawing. So my question is, why is the difference in the position of the pi bonds? In this case, the pi bonds are formed closer to the electron donating group. And these pi bonds are formed away from the electron withdrawing group. साकेत वो इलेक्ट्रोफिलिक सब्स्टिट्यूशन के लिए होता है ऑर्थो पैरा डायरेक्टिंग या मेटा डायरेक्टिंग. This is not electrophilic substitution, it's a reduction reaction. Anyone could answer this question? It's a JEE advanced question.
Wherever
could you
the
repeat
free
the
radical is
question?
stable.
Yes, very good. So let us see. If you take toluene, metal has to donate electrons. This pi bond will shift to the left or will it shift to the right? If it shifts to the left, lithium will come and give an electron here. So I'll get a 3-degree free radical and a 2-degree carbanion. The other possibility is this pi bond shifts here. So lithium will give an electron here. So I'll get a 2-degree radical and 3-degree carbanion. So you have to tell me where will the pi bond shift?
To the left.
Yes, because radical preferred will be 3-degree. Do you agree?
Yes, ma'am.
And carbanion should be here 2-degree. So इसमें pi bond इस तरफ ऐसे shift होगा. इसके बाद से जो mechanism करोगे, you will get your answer. अब इसमें बताओ pi bond कहाँ shift होगा? Lithium has to give electrons. Will this pi bond shift towards the left or to the right?
Right.
Yes. Yes. And why is it so?
Will withdraw electrons.
Yes. So can I say it will stabilize the carbanion?
Yes, ma'am.
Okay. इसका भी जब आगे का करोगे मैकेनिज्म, ये वाला मैकेनिज्म जो दिया है मैंने, when you proceed ahead you will get the product. Okay, you are understood, all of you?
Yes, ma'am.
Did you all finish writing this?
Done.
I'm 1 minute.
Okay.
Done, ma'am.
Okay. So next is addition of halogens. Then you have to do addition of chlorine. So when chlorine will add to the pi bonds. What product I'll get? How many moles of chlorine needed? 3 moles because of 3 pi bonds. So every carbon now will get a chlorine. उस पे H भी है, don't forget that. Every carbon has a hydrogen and now it will get 1 chlorine atom also. What will be the name of this compound?
Hexachlorocyclohexane.
Yes. 1, 2, 3. Numbering is compulsory here. Why numbering is compulsory?
एक कार्बन पे 2 क्लोरीन हो सकता है.
This is wrongly named as benzene hexachloride. Why am I saying it is wrongly named as benzene hexachloride?
Because there's no benzene.
Yes. BHC is benzene hexachloride. This is a very powerful insecticide. Insecticide क्या होता है?
They used to
Kills
kill
insects.
spray on crops
Yes.
to kill
Yes.
the bugs.
Correct. Yes. So this is insecticide means it is used for killing insects. So it's sprayed on crops or plants to protect them from damage. It is sold under the name Gamexine. Other name is Linden. These are the
common names.
commercial names.
Okay.
Commercial names क्या होते हैं?
The name by which they are sold in the market.
Yes. Okay.
Miss, benzene hexachloride is the incorrect name, right?
Yeah, it's a wrong name actually because this molecule doesn't have any benzene ring.
Okay, miss.
Ma'am, I mean, so it's a very strong anti insect spray. So like उसका plants पे कुछ ये होता है क्या negative effect?
नहीं. It's basically used for killing of insects. That's all. That is why we also, when we eat plants, means vegetables and all, we are supposed to wash it thoroughly, na? Because these are all easily carried away by water. So we are not supposed to consume these insecticides. They are actually poison for us also. But in large quantities. So if we will have to consume in large quantities, then only it will be harmful to us. Or did you finish writing this?
Yes, ma'am.
Okay. Now last addition reaction is addition of ozone. There are 3 pi bonds in benzene. So how many moles of ozone consumed here?
3.
Per mole of benzene, you'll need 3 moles of ozone. This is reductive ozonolysis. Will you tell me the product? You have done ozonolysis. चलो बताओ.
मिस एल्डिहाइड बनता है ना,
हाँ.
तो
You'll get
डाई एल्डिहाइड.
3 moles of
कीटोन मैम ना.
3 moles of glyoxyl. इसको glyoxyl बोलते हैं. इथेन डायल. करेक्ट.
Yes, ma'am.
ये ब्रेक होगा ऐसे. You'll put double bond O here, double bond O here. तो यहाँ से glyoxyl बनेगा, यहाँ से भी बनेगा, यहाँ से भी बनेगा. What if you take toluene? Give me the product here.
मिस 2 moles glyoxyl.
Okay. And
Propanol.
Propyne.
1 mole of
One
methyl
common.
1 mole of methyl glyoxyl. Correct.
Yes, ma'am.
Yes, miss.
Yes, Mandar, I'll just show it to you. ये ऐसे break होगा. And what are you going to do? ये CH3 है, C double bond O हो जाएगा. C double bond O और इस पे H है. तो ये बनेगा methyl glyoxyl. और यहाँ से आपको बनेगा glyoxyl और यहाँ से भी glyoxyl.
Yes.
Did you understand, Mandar?
Yes, ma'am.
Okay. Did you all finish this? I think done.
No, 1 minute, ma'am.
Okay. Yes, Rahil, I'll show you the 11th slide. Just give me a moment.
Done, ma'am.
Okay. This is the 11th one.
Ma'am, before this. 1 minute, ma'am. Thank you, ma'am.
Okay. This is done.
Yes,
This is
ma'am.
also. Now what if I take orthoxylene?
One dimethyl glyoxyl.
Glyoxyl बनेंगे? Can I say yes?
हाँ मिस 2.
क्या बनेगा?
Dimethyl glyoxyl.
but you also get this methyl glyoxal. ये कैसे बनेगा? Okay, wait. While doing ozonolysis now, you need to write the resonating structures and get the answer. Okay. Can I say ये जब break होगा, so I'll get CH3 C double bond O, again C double bond O with a CH3. In other words, I'll get this dimethyl glyoxal, correct?
Yes, ma'am.
But if I take this resonating form, ये break होगा यहाँ से, so I'll get CH3 with a carbon having double bond O. Again, there's a carbon with double bond O, but there's an H here, so I'll get methyl glyoxal. Did you all understand?
Yes, ma'am.
So you need to write the resonating structures. Then only you can get the correct answers for ozonolysis. आ रहा है कि नहीं समझ में?
Yes, ma'am.
Yes, miss.
जैसे मैंने अगर ये कंपाउंड लिया है, what is this compound?
Naphthalene.
Naphthalene. इसके भी मुझे रेजोनेटिंग स्ट्रक्चर्स लेने पड़ेंगे, तब जाके मुझे सारे प्रोडक्ट्स आएंगे ओजोनोलिसिस के. इसका रेजोनेटिंग फॉर्म एक ये होगा, और दूसरा ये. So these are the three resonating forms of naphthalene. इसमें से सबसे स्टेबल कौन सा है?
No.
Which
First
is the
one.
more?
First one.
First one.
Why is the first one more stable?
Because it's conjugated in both.
Can I say both are benzenoid rings? Ring A and ring B?
Yes, ma'am.
In 2, the ring A is benzenoid, but ring B is non-benzenoid, correct?
Yes, ma'am.
And in third one, ring B is benzenoid and A is non-benzenoid. Fine?
Oh, yes, ma'am.
So stability order बताओ.
First and then second, third.
Miss 2 and 3 are
Second
equal.
and third equal.
Yes.
Yes, ma'am. They are same structure.
Yes. Okay. तो इसका जब रेजोनेटिंग फॉर्म्स लिखने के बाद ओजोनोलिसिस करोगे तो कितने प्रोडक्ट्स आएंगे?
Ma'am, 3.
ग्लायोक्सिल तो सब जगह बनेगा.
मैम मिथाइल ग्लाइकोल भी बनेगा ना.
मिथाइल कहाँ से आया? देखो इसको जब ब्रेक करोगे तो ये पार्ट क्या देगा? ये जो पार्ट
Miss propane trial.
I'll get C double bond O, C double bond O H and C double bond O H. ये समझा कि नहीं?
Yes, ma'am.
Yes, miss.
यहाँ से भी ऊपर से भी वही मिलेगा, ये नीचे के पार्ट से भी वही मिलेगा. डू यू एग्री?
यस मैम.
Yes, ma'am.
हाँ. But if I break this one, यहाँ से, तो ये कार्बन पे ध्यान दो, ये वाले कार्बन, ये दोनों कार्बन. I would also get this. समझा?
Yes, ma'am.
Yes, miss.
So you have to write the resonating structures and then get the answer. Naphthalene में rings कितने हैं?
2.
3.
2 rings है ना?
Yes, miss.
ओ मैम.
2 है ना, A और B. So number of resonating structures will be n plus 1, where n is the number of rings.
3.
So 2 rings, so 3 resonating structures. Anthracene में कितने होंगे resonating structures?
Miss
4.
Yes. Okay.
मैम ग्लायोक्सिल 2 बनेगा ना?
हाँ, ग्लायोक्सिल पहले वाले में से एक ग्लाइकोसिल यहाँ से और एक यहाँ से, दूसरे वाले में कितने ग्लाइकोसिल बनेंगे?
मैम एक ही।
यहाँ से ग्लाइकोसिल बनेगा,
यस मैम।
यहाँ से भी बनेगा और यहाँ से भी बनेगा, करेक्ट?
Yes, ma'am.
मैम वो इंटरसेक्शन कार्बन्स का ब्रेकिंग से कौन सा वाला बनेगा?
ये वाला ना,
यस मैम।
ये वाला बनेगा ना उसका।
यस मैम।
ये C डबल बॉन्ड O बनेगा, इधर भी C डबल बॉन्ड O, करेक्ट?
यस
that
मैम।
will be connected to a C double bond O,
O।
यहाँ पर भी और यहाँ पर भी C double bond।
यस मैम।
Did you all finish this?
So ma'am, that last one is the that one. Done, ma'am.
All of you are done?
Done, ma'am.
तो एंथ्रासीन के स्ट्रक्चर्स लिख लो पहले and see if you are getting 4 structures.
मैम इसमें फर्स्ट और सेकंड दोनों स्टेबल रहेंगे ना?
हाँ, दोनों ज्यादा स्टेबल है।
1 2 पहले और 1 में 3 4 मतलब इक्वल टू।
हाँ, stability order 1 equal to 2, which is greater than 3 equal to 4, correct?
यस मैम।
Can I say in 1 and 2, in 1 A and B rings are benzenoid and C is non-benzenoid?
यस।
Yes, ma'am.
2 में B and C are benzenoid, but A is non-benzenoid. In 3, A is benzenoid, B and C are non-benzenoid. In fourth क्या कर दिया ये मैंने? हाँ, फोर्थ में C benzenoid है और A और B non-benzenoid.
मैम इसमें स्टेबिलिटी कैसे चेक किया आपने 1 और 3 में?
वही बताया ना, A और B benzenoid है ना फर्स्ट में, 2 रिंग्स benzenoid है.
यस मैम।
सेकंड वाले में भी 2 रिंग्स benzenoid है, B और C.
यस मैम।
थर्ड वाले में
वाले में
सिर्फ
एक ही।
रिंग A benzenoid है, एक ही
Yes,
रिंग
ma'am.
benzenoid. तो ये सारे रेजोनेटिंग स्ट्रक्चर्स लिखने के बाद यू आर सपोज टू अराइव एट द ओजोनोलिसिस का प्रोडक्ट. समझा के नहीं?
Yes, ma'am.
1 and 2 are going to give you the same products. Same way 3 and 4 are also going to give you the same products. So खाली 1 और 3 का ओजोनोलिसिस करना है आपको. समझा?
यस मैम।
Yes, ma'am.
Okay. So this completes all the reactions of benzene. इसके बाद एक्टिवेशन का टेबल आता है जो मैं ऑलरेडी कर चुकी हूँ. Do you agree? I have done it.
Yes, ma'am.
And where have I done it?
COC.
TOC. So the table
हम
for
chapter over.
decreasing, नहीं एक छोटा सा part अभी बाकी है. Decreasing activation वाला table I have already done. Just little bit I have to elaborate on this. Okay. Decreasing activation में मैंने जो दिया है, that helps you in predicting what?
Rate
It helps.
towards
Yes, rate towards.
electrophilic substitution.
Very good. Yes. So using that table, we can very well predict the rate towards electrophilic substitution. I can also predict the directive influence. Directive influence मतलब अगर ये ग्रुप है और इसमें मैं इलेक्ट्रोफाइल ऐड कर रही हूँ, तो इलेक्ट्रोफाइल कौन से पोजीशन में जाएगा?
Ortho.
Yes. Can I say I'll get two products?
Yes, ma'am.
Ortho and para. So directive
Yes.
influence of OCH3 is ortho and para. Correct?
Yes,
Yes,
ma'am.
ma'am.
But if I have a group something like this, this is what my directing group.
Meta.
Meta directive.
Meta directing group. So using that table, we can very well predict के कौन सा ज्यादा reactive होगा towards electrophilic substitution, and we can also predict the directive influence of these groups. So which is more activating, OCH3 or aldehyde?
OCH3.
So can I say this molecule will react faster in under electrophilic substitution as compared to this one?
Yes, ma'am.
Yes, ma'am.
Okay. When one group is there, it is very easy to predict using that table. But when you have more than one group, then how you're supposed to do that part I'm taking now. Can I proceed?
Yes, ma'am.
Okay. Now supposing if I have, say if I have NH2 here, and if I have say CH3, can I say both are activating?
Yes, ma'am.
But which is strong, more activating?
NH2.
NH2.
So NH2 will decide कि electrophile कहाँ जाएगा. So the one which is more activating always decides the entry of the electrophile. So electrophile will go in ortho position here. Para पे तो जा नहीं पाएगा क्योंकि para पे CH3 है. Para पे तो जा नहीं पाएगा क्योंकि para पे CH3 है. समझा?
Yes, ma'am.
Yes, ma'am.
So if there are two activating groups, the one which is more activating will always decide कि electrophile कहाँ जाएगा. Now what if one is activating, say I have OCH3 and the other is deactivating, तब कौन decide करेगा?
Activating one.
हाँ, तब भी activating ही decide करेगा और electrophile वहीं जाएगा. आ रहा है कि नहीं समझ में?
Yes, ma'am.
What products can be formed here? The electrophile can enter this position.
Yes, ma'am.
That will be one product, and the electrophile can also enter here. Nitrogen is what directing group here? Ortho and para. correct?
Ortho para.
Ab, wait. If I change this also, say to NH2. If I ask you to compare between this compound and this compound, which will be more reactive towards electrophilic substitution?
Second. First.
First one.
Reason for that.
Second.
Let's say this is directing the electrophile to this position, correct?
Yes, ma'am.
Yes, ma'am.
And this is what directing group?
Meta.
So
Meta.
this is also directing it to the same position.
Yes, ma'am.
पर इसमें क्या हो रहा है? इसमें नाइट्रोजन इज डायरेक्टिंग इट हियर और ये कहां पर डायरेक्ट कर रहा है?
उसके बाजू में.
इसमें, am I right?
Yes,
Yes,
ma'am.
ma'am.
So are these two groups assisting each other to the same
No.
position?
No.
but यहाँ पर assistance आ रहा है aldehyde का because it is also directing the electrophile to the same position. Am I right?
Yes, ma'am.
So this will be more reactive than this one. Did you all understand this?
Yes, ma'am.
Yes, ma'am.
Okay. तो जब second group का assistance मिलता है तो वो molecule ज़्यादा reactive होता है. So when you have activating and deactivating, the activating group decides. What if both are deactivating? देखो aldehyde भी है, supposing और nitro भी है. Both are deactivating. तब कौन decide करेगा?
ज्यादा डीएक्टिविटी.
Yes, ये decide करेगा. This will decide कि कहाँ जाएगा electrophile. तो जब तक activating group है, वो ही decide करता है कि electrophile कहाँ जाता है. But if both are deactivating, then it is the more deactivating group which decides the entry of the electrophile. Did you all understand what I have said here?
Yes, ma'am.
So benzene का सारा I have completed. अब दो तीन एक चीज और बाकी है इनफैक्ट. What assistance you want me to repeat this part? देखो NH2 is directing the electrophile in the ortho position and aldehyde is directing to its meta position. So both are directing to the same position. In other words, aldehyde will assist NH2 in directing the electrophile to the same position. But यहाँ पर नहीं हो रहा है. यहाँ पर N will direct it to ortho, but this is going to be directing it to meta. तो इसका meta ये है, पर इसका ortho ये है. तो इसको NH2 को assistance नहीं आ रहा है इसमें. That is why this compound, the first one, is more reactive than the second one. ठीक है, समझा ना? Okay. Now if I take naphthalene. Okay, naphthalene का अभी numbering. अच्छा, this is going to take time. I'll need at least half an hour. अभी कितना time हुआ है?
10 minutes.
9:20. You have 10 minutes.
So I'll start this in the next lecture. This is going to take me half an hour more. So I don't want to start it now. Fine.
Ma'am, you will do it tomorrow in the doubt lecture.
If you want, I can do it tomorrow. Yes, I can complete it. I'll do it tomorrow then.
Yes, ma'am.
And then after that, I'll take the TWT for doubts.
Yes, ma'am.
Okay. So tomorrow I'll complete your chapter. But now till whatever I have done here, you can complete your entire booklet of aromatic hydrocarbons.
Okay, ma'am.
So start completing the aromatic hydrocarbons also, because next week I'll try to complete alkyl and aryl halides. अगर 3 lecture मिले तो 2 मिले तो that will also remain little bit. ठीक है, those who are done can leave. Those who are still copying.
Thank you, Miss. Bye, Miss.
Yeah, bye.
Thank you.
Yes, Rahil, aromatic is an important part of your mains. Yes. And it's a very, very easy topic. So you'll be able to solve the questions. In fact, you don't need my help. That chapter is very easy.
Ma'am,
Huh.
ma'am, in this, in the compound which you have labeled as 1, the electrophile will attack more faster, you mean to say, right? When you say reactive, because
Yes,
both
yes,
are
yes.
systemic,
Compound 1 is more reactive, means the
Direct.
electrophilic substitution will be faster in compound 1 as compared to 2.
Okay.
ठीक है? Okay. चलो, done. Okay, I'm ending the class then. Fine.
Thank you, ma'am.
Chalo, bye all of you.